Welcome to the very first Data on Kubernetes Town Hall event. We are super excited to have everybody here. My name is Melissa Logan. I'm the director of the Data on Kubernetes community, founder of Constantia.io. I'm super excited for our first DoK Town Hall today. We have some great talks, and we've got some updates from the DoK community about ways you can participate, upcoming events, projects that we're working on within the community. We're always looking for people to contribute to those. So we will share those with you and hope you can collaborate with us. And then we also have two fantastic talks. We have the folks from Comcast here. They're going to talk about delivering business outcomes and improve DevX with data services running on Kubernetes. And then we also have a talk from Holden Karau of Netflix talking about how Kubernetes works and or doesn't with Apache Spark. So she is a Spark committer and we'll be talking about her experiences there. And then we'll have a fun little short quiz at the end and we'll do a t-shirt giveaway. We have a pretty cool Run DoK t-shirt. If you like Run DMC as much as I do, then you might love this t-shirt. So hopefully we've got some Run DMC fans in the mix here. Without further ado, we'll start with some community updates from Data on Kubernetes. We just wanted to ask a community poll. In general, this is the first time we're doing this series. We'd love to know what topics you'd like to see us cover. So if you have ideas about things that you have been wanting to know, burning questions about Data on Kubernetes, please just write in the chat. We'd love to hear what kind of information you would love to hear from DoK. Wanted to share a few updates on some events that we have just completed or that are coming up. So recent events that we went to, we of course went to KubeCon in Amsterdam. We had a couple of things going on there. One, we hosted a very first Amsterdam meetup with some folks, local folks there. We had two great talks, one from ING and one from some folks who had helped get databases on Kubernetes for the Dutch government. Great talks. We had about 100 people show up. It was at the beautiful offices of Adyen. It was a new space on the Rokin in Amsterdam, just an absolutely beautiful office and just great questions and interaction from the audience throughout that event. The folks who presented are now co-organizing another event to be likely in June in Amsterdam. So if you're in that area, we'll keep you posted on when that is happening. There was also just yesterday before I go there, in Amsterdam, we also had a panel about operator landscape at the KubeCon event itself. It was myself and three other folks from the Data on Kubernetes operator SIG, and we talked about the Kubernetes operator landscape. I think there were about 500, 600 people in the room, a few other 100 folks online virtually. Just a great discussion about the challenges that people are facing with operators. We asked people to raise their hand and said, who is using operators, who is running data workloads? And it was like 60% of the folks in the room were raising their hands. So we're really seeing a lot of maturity in usage of Kubernetes for data workloads, and there are still challenges. So that's what we were talking about in that talk, and we talked also about some solutions for that. So you can watch the replay of that talk. I think we have a blog up on the DoK.community site that recaps our time in Amsterdam and has a replay for that talk. We also, just yesterday, the Bay Area DoK meetup group hosted their first official event as their own independent Bay Area meetup. And they had great registration for that. I think it was like 70 people registered, maybe 20, 25 people showed up at the venue. They had some great talks, one about Kubernetes operators, one of our favorite topics, as you might hear as a theme throughout this conversation today. And another one, I can't exactly remember the title. I know Lisa is on the call and she was there. She might be happy to share in the chat that title. And then they're planning their next one. So they're trying to do these on a monthly basis. So if you're in the Bay Area, we hope you can join that event. If you have talks that you want to give at the Bay Area event too, get in touch with the event organizers through the meetup link. So as I mentioned, this is our very first this is our very first town hall for the May timeframe for DoK. We have the June one, in fact, scheduled. We just got it scheduled yesterday. That one will include talks from Matt Menzenski, who is from Pay@Gov. He'll be giving a talk about unsticking ourselves from glue, migrating Pay@'s data pipelines to Argo workflows and Hera. And then Robert Hodges from Altinity will be talking about how to find a Kubernetes operator that really protects your data. This is a talk that he just gave yesterday at the Bay Area meetup. He'll be giving it virtually for all of us. And then finally, in terms of events, we have a DoK Day hybrid event at KubeCon North America in Chicago in November. The CFP for that will be open in the next 4 to 6 weeks. And if anybody's interested in sponsoring that, the Linux Foundation is organizing that event for us. We have a contact we can put you in touch with if you're interested in sponsoring that event. So I think that is it for all of the events. If you have any DoK-related events that you're going to or want us to highlight in our newsletter or elsewhere, let us know in the chat and we will be sure to do that. The next update I wanted to share was about the DoKC operator SIG. So the operator SIG was created last November as a place for the community to come together and tackle some of the challenges that we continuously hear about Kubernetes operators. If you haven't read the Data on Kubernetes reports that we've produced yet, please do. They illuminated a lot of the challenges that people face with operators. And from those reports, we thought, well, how can we as a community help solve those problems? And created the operator SIG to bring people together to talk about how we can do that. So since we've launched in November, there are a number of projects that we have in process. One of them is an operator feature matrix. This is an opportunity for us to compare different features of operators. So one of the things we heard about in the survey, in our report and survey, was that there are varying degrees of quality of operators. And often people don't know what they're getting into until they get in and kind of play with it for a while. So the operator feature matrix is intended to help people evaluate operators against each other and different features that they're looking for. So that's in process now. If you want to participate in that, if you write an operator, go to the operator SIG Slack channel and you'll see the GitHub repo and all of that information there. Another project that we're working on right now that's almost coming to a close is we've been collaborating with the CNCF storage tag on a databases on Kubernetes white paper, how to run databases on Kubernetes, how do you deal with different elements of that. Our members from our SIG have been working on that for the past few months, and it should be published, I'm guessing, in the next month or so. It's in the final review stages. If you want to take a look at that, again, it's in the SIG Slack. The last project that was recently introduced was an operator security hardening guide. So in the last DoK survey, again, we found that the #1 criteria with which people are evaluating whether to adopt an operator was security. So a member of our community proposed an idea of creating a general white paper to help people know how to secure and harden their operators. So that is just getting started. If you want to participate in that, again, join the Slack. There is a new project being proposed in our next operator SIG meeting, which is a distributed systems operator interface. That is another member of our community, Adeep, talking about how we can come together to try to solve this problem as well. If you want to hear about that, we'll be discussing that in the next operator SIG meeting. I don't know the date offhand, but it's either next week or the week after. So we meet bi-weekly for the operator SIG. In the Slack, you can see the agenda. It has a public calendar in there, a link to the agenda, a link to all past notes, a link to the different proposals. So you can take a look at that and get up to speed. Final project of the operator SIG is an operator roundtable that we're hosting next week on May 25th. So you might have seen a survey that we just sent around on the Slack and social media and our newsletter directed at people who write operators. So if you do write an operator, we'd love to get your feedback on the survey. What are the challenges and issues that you have when doing that, when running them in production? And if you want to be part of the conversation that we are hosting with other operator writers, that's May 25th. That will be facilitated by members of our community from Google, Akshay, and Michelle. And just let us know in the survey if you want to join, put your name and email in there, and we'll add you to the invite. So that is our updates from the operator SIG. As you can tell, operators are one of our favorite topics in the DoK community. We talk about them quite a lot. We know it is challenging for many of you to work with them. And that's not to say all operators are bad, I should say. Some of them work very well. It's just that sometimes you just don't know. And it's a new thing. We're all still learning together how to do this really well as an industry. Finally, I just want to mention a few different ways you can participate in DoK. We are always looking for talks for these town halls, for local meetups, for DoK Day. We have a form, a speaker bureau form, where you can submit a talk if you would like to give one. The types of talks we look for are end user case studies, use cases and best practices for data on Kubernetes, any kind of ecosystem talks, so things like Apache Spark and Kubernetes, how those work together. No vendor talks will be accepted, so please don't even bother. Just give us your best talks that are case studies and best practices, and we would love to have you present. And then, of course, the Slack is there for asking and answering questions. So please continue to use that and meet other people in the community. We're looking at ways to help you connect one-to-one with other folks, do some kind of speed networking or speed meeting type activities. So look for that on the Slack in the future. Without further ado, I will turn this over to Greg and Charles, who will from Comcast, who will talk about their experiences running data on Kubernetes. Over to you.
All right, thank you so much. It's really a privilege to help kick off this first ever DoK Town Hall. I'm Greg Otto. I'm from Comcast. I lead our DevX, or Developer Experience Platforms team. With me here today is Charles Zhu. He's one of our engineers and actually makes all the things that I wave my hands about happen. And so today we're going to walk through our journey, both from a technology perspective, but we also want to bring the human perspective, right? So as we go through these transformations for our customers as well as for our engineers, we wanted to bring both of those perspectives to you. Jump into the next slide here. So I don't think this is unique to Comcast, but a lot of times our developers sort of feel like this. And we had a specific challenge, a business critical project where, as part of a middle tier, we needed to create a number of data services. And the challenge that we had was that different development teams were creating them themselves. And there's like hundreds of these that need to be created. And it was taken over 2 months and over 300 hours to create a single service. And as you would imagine, they're all artisanally handcrafted. So we had a cloud full of snowflakes. So then the approach that we took was, in order to reduce the cognitive load on our developers, we do that through paved paths that are thoughtfully connected together. And at a high level, our solution couples a low-code framework with our DevX paths. And of course, that includes data on Kubernetes. And the outcome from a developer journey perspective is that a developer goes into an interface, they declare some metadata, push go, and then the code is generated, the pipelines are created, testing ensues, and then the application and data is deployed in 3 different regions on our platform, so geo-distributed. And so that all happens in about 30 minutes. Okay, so definitely a big improvement there. And so we solved a bunch of different primitives. I'm not going to drain it and go over each one of these, but some big parts of this, our global ingress, removing the need for secrets and password management. So that keeps our friends in security and audit happy. So being able to handle those things automatically for the developers. And then all the database configuration and deploy and connecting and wiring to the applications and solving all of these primitives on behalf of the developers is really what takes a lot of the toil and the time, out of that journey. And then it's also important to note that a lot of goodness for day one, but also all the day two and beyond is also like pretty near free for the developers. So things like scaling those data services, all of upgrades and things like that, traffic management, that all happens by the platform. So these are some of the outcomes that we've been able to get. We run thousands of services on Kubernetes today, but we're still pretty early in the journey. And this is not trivial. This is hard stuff. And as any transformation, it's also a challenge for the human perspectives as well. So we don't want to forget the humans. And with that, I'm going to turn it over to Charles.
Hey, thanks, Greg. So thanks everyone for joining today's town hall. So we all know that the Kubernetes technology has been available for many years now, right? But when you're deploying a database on the Kubernetes platform, the majority of the current solutions only allows you to deploy your database on a single site or single cluster. So no matter whether it's a Helm chart or an open source operator, they don't really provide you any capability which will allow you to deploy your database across multiple Kubernetes clusters. So the problem with this kind of single site or single cluster deployment is that it is really not enough, both from the high availability perspective and from the localized performance perspective. So in case a single site or single site cluster goes down, your database application will become not available anymore. And for the user perspective, if they can access the data from a local cluster, the performance definitely will be much better than access the data from a remote cluster. So we definitely need a geo-distributed orchestration method to deploy our database across multiple clusters. But we don't have a lot of solutions available right now, within the Kubernetes community for this kind of multi-cluster deployment. The geo-distributed data on Kubernetes is still relatively an uncharted area. So because of that, because of the lack of the current available solutions, our team have been trying to develop our custom controllers or blueprints for multi-cluster database deployment. In that kind of scenario, the first thing that we needed to solve is a cross-cluster communication or pod-to-pod communication. So we use technology such as like a cluster mesh or service mesh to achieve those kind of cross-cluster communication so that the data running on each pod can be replicated to another data running on a different cluster. We also needed to work on external networking so that the application running outside of the Kubernetes cluster can access the database running inside the Kubernetes cluster. On that front, we use technology such as like a TCP ingress or global DNS resolution. Deploying database, no matter whether you are doing it on a virtual machine environment or on a Kubernetes platform, besides this orchestration piece, it also involves a lot of day two operations. So for example, like database backup and restore. If you don't have a really good backup mechanism, so in case something happens, you may lose all of your data. And if you don't have a recovery solution, then your application may suffer an extended downtime if something, disaster happens. So our team have been trying to build all these day-to operations into our customer controllers so that we can make sure the database running on our Kubernetes clusters can be backed up safely and restored quickly across multiple Kubernetes clusters in case we need it. The federated observability is also another critical piece for running database on the Kubernetes platform. So in our multi-cluster deployment scenario, that means we have to collect the metrics from different pods running on each different Kubernetes clusters. Then we have to consolidate all these metrics into a federated view so that we can have an overlook of the whole deployment across multiple clusters. So these are just some of the major tasks that our team have been building for our customer controllers. So this is just like Greg mentioned, right? It's not a trivial, solutions. As we all know, the multi-cluster deployment on the Kubernetes itself is still a relatively an uncharted area. Of course, we have noticed that some of our vendors or partners have been developing their enterprise license like operators or controllers for deploying database across multiple Kubernetes clusters. But from our experience, most of those solutions are either still in a developing stage or their design doesn't really meet our requirements. So we have to spend a lot of time and a lot of energy to find the right solution to build our customer controllers so that we can utilize that to do the multiple cluster deployment. Although it's not easy, but we have already made some progress. We were able to develop at least a couple of prototypes, which allow us to deploy the clusters across multiple clusters. But of course, we still have a lot of work to do to make it the final version. So although not easy, but we are really excited to make our solutions more generally available as the trusted pattern, for our team to consume in the future. So we are quite optimistic, about our journey, even though we are still early on our developing stage. So next slide is I'd like to talk a little bit about my personal journey. So just like Greg mentioned. So today I'm here talking about Kubernetes, right? In our Kubernetes Town Hall. I guess many of you in the audience may think I must have been working on Kubernetes for quite a while. So to be honest, believe it or not, for the past 20 years, I actually have been mainly working as a traditional database engineer for various database technologies. I actually didn't have too much Kubernetes knowledge at all. So the first time that I ever got involved into a Kubernetes project was actually back in October 2021. So at that time, there was an internal request to orchestrate a graph database across multiple Kubernetes clusters running on our internal cloud platform. So that was really a big challenge for database team and myself at that time, because as I said, we didn't have too much knowledge about Kubernetes at all. And just like we mentioned, running database across multiple Kubernetes clusters itself is still a challenge. I actually literally started, this project by, watching tutorials on the internet. But eventually, by working with our vendor support and our internal cloud team experts, we were able to deliver this solution within 4 months. That actually literally becomes the first geo-distributed database deployment across multiple Kubernetes clusters, within our organization. That was really a good experience for me. And to be honest, really, changed my opinion of running database on Kubernetes at all. But of course, we needed to find better solutions, right? We needed to find easy solutions. We can't always, let's say, spend a couple of months to deploy a database running on multiple Kubernetes clusters. That's why our team have been spending a lot of time and energy to build our custom controllers so that we can deploy our database across multiple clusters. But of course, this is not easy even from the human perspective. As I said, none of the DBAs had a lot of Kubernetes technology. So it's really a big learning curve for all of us to get familiar with this technology. And also, we still have some concerns. For example, we are not 100% convinced that the performance of running large database on Kubernetes clusters can be as good as running them on the virtual machine environment. Although, we had a lot of talks with our cloud team experts, but we still needed to see it to prove that. That's why we're doing a lot of benchmarkings and the stressful test to make sure that the performance is good. And also in the meantime, we have to prepare ourselves to be ready for the large scale deployment in the future. So there's one good thing that happened that after we completed that graph database deployment is that our database team now is actually merged with our cloud team together under one team, under Greg Otto. So that integration actually, in my opinion, really empowers us to develop a next generation automated database orchestration solutions across multiple Kubernetes clusters. So it's not an easy journey, and we are still learning. We are still, researching to find the right solutions, but we are quite optimistic. And personally, I do believe, just like we moved away from physical machine to virtual machine, probably let's say 50 years ago, in the future, I believe we will have more and more database running on the Kubernetes platform. Because generally speaking, it is more economically efficient of the running the database on a Kubernetes platform than running it on a virtual machine platform. And also the Kubernetes technology itself provides a much better self-healing capabilities than the virtual machine. So I really actually enjoyed my journey from like a traditional database engineering to be a cloud database engineering. And I will keep learning it. And I enjoyed it. I'm happy to be in this transition. I'm now handing back my presentation back to Greg. Thanks, everyone.
All right, thanks, Charles. Real quick, just to wrap this up, distributed data on Kubernetes is real, it's here. You heard how we're able to take developer journeys from months down to minutes. And then you also heard from Charles, like where we literally, put structure. We have in our one organization, our cloud native teams, as well as our data team. So blending those two worlds together structurally within our company. Lots of opportunities. We're learning a lot. We really want to hear from folks in the community. So please reach out to us on Slack. We'll provide the presentation, but we are in the DoKC community. So definitely don't be shy. Reach out to us. And last but not least, do not forget the humans. So, thank you very much.
Yeah, that's awesome, Greg. Thank you so much. And I was chatting with Greg just during the talk because multi-clustered continuously comes up in DoK as a challenge because it is not a solved challenge for deployment. And there are a few groups that, in fact, it'd be great to have on the DoK Town Hall. There is a multi-cluster SIG in the Kubernetes ecosystem that we'll reach out to and see if they can come talk. There are a couple other projects that we know of that that are looking at this problem as well. One is Apache Unicorn. It's YUNIKORN. And then there's a Volcano project that's in CNCF as well. And I think all of these are taking a look at multi-clusters. So because we hear this continuously, we'll invite them to come on a future town hall. So I'm glad that you shared that today, and it's not a unique challenge to you. Awesome.
Thanks.
Does anybody have any questions for Charles and Greg? Didn't see anything in the chat, but we're happy to, they're happy to answer questions here, or if you think of things after the fact, as they said, they are on the DoK Slack, so you can reach out to them there. If nothing else, we will go to, thanks, Greg, appreciate it. Thanks, Charles. If no other questions there, then we'll go to our next talk. Holden couldn't be with us live today. She had another event, but we are very excited to have this talk about, she'll be covering a lot of the best practices from trying to deploy both small and large scale Spark on Kubernetes. And without further ado, we will have Holden tell you all about it.
Hi all, I'm going to talk to you about Spark on Kubernetes. This is going to be like a lot less formal because I'm thinking that's kind of the town hall vibe. If I'm wrong about that, this won't be the first time that I was a lot less formal than something that was supposed to be pretty formal. In fact, I am slowly walking on my treadmill while hydrating. And it's not coffee. This one's coffee. Because I'm getting ready to go to Electric Daisy Carnival, which I'm really excited about. But I am definitely not in shape for that. So, yeah. So, who am I? My pronouns are she or her. I am on the Spark PMC, but I want to be clear that while I am on the Spark PMC, I'm not necessarily talking on behalf of the Spark project, right? These are all my own opinions. I've been around, I've been at a lot of different companies. I'm going to talk about sort of experiences, not just from Netflix, but also at these other companies. I'm also a co-author of a few different books about Spark and related data processing tools. And I also do live streams of open source. If you're looking for something to fall asleep to and you like the sound of someone swearing at a computer. I also got paged like a bunch, but we'll go into that later. And yeah, with that stunning intro, my organization, I don't run it, to be clear, right? Like I work in this organization, but they are hiring at Netflix. So if you're interested in doing data engineering or, you know, making data engineering tools better at scale, we're hiring, and, you know, check out the jobs. Okay, that was not supposed to happen. There should be some more flags here. Ah, there we go. Okay, we'll just continue. So in addition to who I am professionally outside of work, I'm trans, queer, Canadian, and in the broader leather community. For those of you in America, Pride Month is coming up, and so that's an opportunity to, you know, maybe get involved with, you know, your local community if that's something that you care about. But also, I think just as people who are building data-powered tools, and a lot of those tools are now being used to train machine learning models, it's important for us to have diverse communities building these tools and building the models with these tools. And part of that means talking about where we're all from and realizing if we are all from the same place, that is not good. It is time to make the table larger. It's almost always time to make the table larger, but especially when you realize, you know, everyone went to UC Berkeley, class of '09. Just an example, I have not been to UC Berkeley. Well, I went to a concert there, but they don't give out degrees for that. So, what are some of my possibly relevant biases? So some things to keep in mind. My advice is going to come from the perspective of someone who's used to working with really large-scale data sets. I've worked on Spark for a really long time, and so I think that skews my view. I don't come from a Kubernetes background, right? I come from a Spark on Yarn background and then shifting into running Spark on Kubernetes. I've contributed code to other tools. I really like strongly typed systems. I think they're kind of cool. I don't really love YAML. I think functional programming is pretty cool. And I've worked on some other tools that I sort of gave up working on pretty quickly as well. And I also think my dog is really awesome. That one is probably not going to impact us too much unless he decides to come up and join us. But in the last practice recording, he did not. So I think we can say he's probably not going to come up and join us. And yeah, as an aside, my voice probably sounds a little rougher today than I would want. but I did get paged like twice in the last 24 hours, I think, and so my sleep is not ideal, and so I am sleepy like the professor. To be clear, the professor is the name of my dog. He is amazing. Okay, cool. So, running Spark on Kube. So I want to be clear, I'm going to talk a lot about sort of the experiences of migrating Spark to Kube. And this is because I believe that a lot of people who are looking at running Spark on Kubernetes are probably already running Spark somewhere else, right? If you're new to the Spark project, that's wonderful. I'm super glad you're here. This is really great. Your life is going to be a little bit easier. And as we switch cluster managers, though, for those of us who have existing working jobs, we may not remember all of the context around those jobs, and then we have to move them, and then we have to relearn a lot of this context, and that can be a little bit frustrating. And yeah, so that's one sort of aspect of this. I'm also going to talk a little bit about Spark at sort of a smaller scale. Implicitly, I run Spark on K3S on a sketchy rack in Fremont, California. If anyone's looking for a low-cost IP transit in Hurricane Electric Fremont 2, give me a shout. I realize there are probably all of about 6 people looking for that, so you are probably not one of them, but you never know. Here I am working on that very sketchy rack. The other night, I believe I was flashing new bootloaders onto the NVIDIA Jetson AGXs so that I could install a modern version of Linux, so that I could install a modern version of CUDA, so that I could do something with Spark on CUDA on Kubernetes. So it's turtles all the way down, and eventually you end up with someone in a data center pressing some buttons. The other thing that I sort of have some experience with that we'll talk about briefly is running Dask on Kube and Ray on Kube. I do those only in my free time. I don't do that for work. We do run Ray at Netflix, but we run it on a different system that is not our Kubernetes sort of inspired one. So let's talk about some best practices for running Spark on Kubernetes. The first one is Blob Storage. I like to think of Blob Storage as like a swimming pool. Also, it gives me an excuse to share a picture from Mermaid School, which I managed to trick one of my employers into paying for with the educational reimbursement. So that was fun. But okay, more seriously, this is really important because for people who have been in the Spark on Yarn world, we have HDFS. HDFS is amazing, but as we come to Spark on Kube, that's not going to be there for the most part. And so we need to look at using Blob Storage. We could also look at using, some of the other wonderful Kubernetes storage APIs. I do not think, for the most part, they're really well suited to us. I think Blob Storage is really the way to go for our systems here. One of the patterns that I've seen be relatively successful is shadow writes, so where we are not blocking on our writes to Blob Storage, but we're sort of doing a delayed write back in a non-blocking fashion. The other one is only doing this for files of a certain size. If we've got tons of little tiny small files, that's probably fine to store in like a cube, empty dir, some local storage, right? But these really large files we might start to run out of disk on a local node, or at least out of our available disk. Another one is decommissioning, and so decommissioning is a bit of a strange concept, especially for people coming from Spark on Yarn. I like to think of it as like what your nighttime routine is, right? Like you go to the really fancy McDonald's, you pick up a nighttime snack, some French fries, you come home, you brush your teeth, and you go to sleep. I didn't have a picture of me brushing my teeth, so I got the McDonald's one up there. But it's very similar for Spark. We want to let the executors know that like, hey, it's time to start cleaning up, right? It's time to put away the toys that you took out so that another executor can go and find the toys or files when we need them. The other one is, right, Spark and Dask and Ray all suffer from this problem of, while we can handle the loss of individual executors, we cannot handle the loss of the driver. Different words for driver and the different ones, but essentially the main client driver thing, that abstract sort of concept, we cannot lose it. We do not really have functioning high availability. And in those cases, we need to just set really high priority and hope. Also, incidentally, this is really useful and important here, is to set up the ownership links between the driver and the dependent resources. Because if the driver fails or goes away, we want to clean up those dependent resources quickly so they can be made available to another program. One of the other things that I think is a best practice for the future, that is something that we don't do yet, but I think we could do in the future, would be expressing dynamic priorities. And so not every executor has the same cost to lose, and I think it would be really good if we could more dynamically express the disruption cost of the different pods. Unfortunately, we don't really have a good way to do that right now, and so that's a future thing. I hope we get there someday. Another best practice is putting the driver in the cluster. Now, to be clear, unfortunately, there are some situations under which you cannot do this, right? You do need to run in client mode or have a remote connection or whatever sort of different terminology or different tool uses. But in general, right, much like having Professor Timbit in the chair, things are better when they're together, right? If they're separate, if there's a problem with Professor Timbit getting what he needs from the chair, that can block all of our operations. And in fact, in Spark, Dask, and Ray, if there's problems with the driver, it can cause the entire job to fail, right? And so communication with the driver is super important, and it's really good to have it be in the same cluster. Now, if you can't do that, right, the alternative is to have it in the same cloud or availability region, right, if this is possible. If not, good luck. You'll probably run into network issues that cause your job to fail, but you can restart it. It's not the end of the world. Another sort of interesting best practice that is different between the tools is whether you should deploy directly or with an operator. And now, best practice here is a little fuzzy. Ray and Dask recommend using the operators to deploy. Spark, on the other hand, does not. If we look at how to deploy Spark, running Spark on Kubernetes, the documentation is very much focused on using Spark itself to deploy on Kubernetes rather than using an operator. There are, of course, operators that you can use, and it'll be interesting to see if Spark shifts over time, but for now the recommended path is sort of the direct or non-operator approach. Another sort of pattern, and this, if you're lucky, you've probably never had to think about this, is I do not think you should share your Dask, Ray, or Spark clusters. I think it's totally fine to share your Kube cluster, but while these tools do have different ideas of multi-tenancy to some degree, the level of isolation that they provide is really not ideal, and multiple applications in the same cluster is, I consider, an anti-pattern. I've never seen it go particularly well. You may, of course, have different experiences, but I think that Kubernetes provides us with a sufficient level of resource sharing that we're better off just using Kubernetes to do a resource sharing, and depending on dynamic allocation, to give back resources that we're no longer using. This is one of these future things. It's only somewhat of a future thing in that we're actually working on it, whereas the other thing that I mentioned that was a future thing is like, I should work on this one day. So one of the things that I think we should do is automatic config rewrites. And this is going to lead into the next point where we talk about using historical information. But I think that there's a bunch of new settings that we need to specify in Spark on Kube that we don't have to specify in Spark on Yarn. And I think we should try and automatically set them for the user based on either historical information about previous runs of the job or sort of inferring it from templates. I think this makes a lot of sense also for upgrading or migrating jobs where we might want to automatically set legacy flags on old jobs that we're running with newer systems, but newly created jobs, we don't want to set those same legacy flags. One of the places where I think this really comes into play is previously shared resources, right? So we can think of, maybe Professor Timbit just implicitly shared this RAF with whoever was around, but now we actually have like a resource allocation process, and you have to like actually request the little floaty thing. More accurately, you're more likely to encounter this around disk space rather than little floaty objects in a lake or a river on Kubernetes. And what this comes down to is that in some situations, most of the apps will have just been just fine. Everything will just work when you move them over, but there will be a few that were depending on this local shared disk resource, and they're going to fail. Now, there's a few different things that we could do here, right? One is we could like make it the responsibility of the user to deal with that. They're probably not going to be super stoked about it. The other is we can detect the failure, and we actually have a bunch of really cool tools to detect and classify failures. And if we detect this failure during, say, an automatic migration, we could increase the amount of disk that that job is asking for. We could also, in theory, look at historical information, but on Yarn, we don't have any built-in good graphs of what local disk space is being used by the different processes. So you'd have to write your own sort of tool around that. Another thing that's super important that we need to do is automatic validation. It's just not optional anymore. So there's different kinds of validation, right? There's correctness validation, which is super important, but if you're moving from like Yarn to Kube, you're probably not going to run into correctness issues, although you might, right? Like one situation where you could definitely run into correctness issues is with like a Python virtual environment where the versions change and now you're actually getting completely different results out and you break recommendations, right? And to a certain degree, right, like correctness testing is a little bit easier, right? We can compare the tables that are output by these different jobs if they're tables, and I've got some tools to do that. But performance is fuzzier. And this is because there's huge variance in terms of Spark jobs and how they run, especially because we're running in shared environments in both situations. And so I think, unfortunately, the automatic validation of performance is really complicated, and you'll have to run many iterations of the same job. They don't have to be throwaway runs, right? Like they can be actual production runs, but you compare historical averages and deviations with the new average and deviation on Yarn versus Kube, and that's something where we need a little bit more tooling. But there's some fantastic folks working on it right now. Another best practice is to use resource profiles, right? Regardless, ESP32 probably can't be scheduled to Kube, but like, do we want to run on a tiny little machine? Do we want to run on like maybe one of these machines? Maybe we want one of the GPU machines. Maybe we're okay with running on the really weird kind of janky machine that I got from eBay. Actually, most of these machines are from eBay. They're my personal project. But like, maybe we're okay running with like a few gigs of memory. And so it's important to use resource profiles in Spark, because through those resource profiles, you can tell Kube like, hey, this task, it really doesn't need a lot of resources. And in doing that, you can save a lot of money, especially if you are running in the cloud. The furthest to the right example. But even if you're running like on-prem, or in my case on my little rack down in Fremont, having these resource profiles will help you make more efficient use of your cluster. Okay, that's really all that I have. I hope this was interesting. If you find these kinds of problems fun, if you want to like work on making tooling to automate migrations from legacy clusters to new clusters, or if you're just interested in making data tools scale, the data organization is hiring at Netflix, and I hope you will consider applying. And yeah, have a lovely rest of your day. If this is the first talk, enjoy the second talk. If this is the second talk, hell yeah. Have a good one. Bye, y'all.
Awesome. Thank you so much, Holden. We hope you have a blast at EDC. There are a couple comments I wanted to mention that we saw on the chat. One person said a team at Comcast has been running Spark workloads on Kubernetes, and they enjoyed the ability to dynamically allocate resources and share the infrastructure for different Spark jobs. So that reduced their infra footprint tenfold. I mean, that's pretty awesome. And then we also asked Holden if there were trade-offs between deploying Spark, between deploying with Spark itself versus an operator. It sounded like the recommended path was through Spark itself right now. What benefits would you get with one versus the other? And she said deploying Spark directly is better for dynamic allocation flexibility, but the operator can result in much easier to understand and manage lifecycle, as well as, in her opinion, nicer way of specifying a lot of Kube-related config that are difficult to express when deploying Spark directly. So really good feedback and information today. Thank you, Holden, for joining, and we hope you have a blast. We are now on to the last part of our DoK day. So we have just a mini quiz, and we have a t-shirt to give away to you folks. I see Vitaly saying tenfold is a conservative estimate. So yeah, that's just amazing. So DoK quiz, Diogenes, you want to bring it up? I think we have a quiz. You have to log into a link. So look at this link. If you're using it on your phone, you definitely want to be looking at your phone. You want to be looking at the app and not at the Zoom, because speed matters in this quiz. So you want to be pushing the buttons and looking at wherever you're looking at this link. Let's see. Do I need to pull this up, Diogenes, or are you going to pull it up on the screen here?
I'll pull it up.
Okay, thank you. So it's just a short quiz, just for fun. We have a couple of questions to ask you. And then if you are the winner, please just email Diogenes at DoK.community. I'll put the email right in here, or you can find him on Slack, and we will get your t-shirt mailed to you. Okay, so go to menti.com. Code is 69604621. We've got 11 people in the quiz. If you want to start, get in there. Otherwise, let's go ahead and get it started now. What are the questions going to be? I haven't seen them, so I don't know what they are. What does the data on Kubernetes community do? What do we do? I hope you all know the answer to this question. Help end users connect, host events, produce the DoK report, special interest groups, or all of the above. Hopefully this is a no-brainer. Yes, all of the above. We do all of these things. That is why we are here. All right, let's see who got that, who answered the quickest on this one. Oh, it didn't show the leaderboard. Usually there's a leaderboard. Okay, question 2 of 3. Who's going to get this one? Faster answers get more points. Next question, databases are the #1 data workload organizations bring to Kubernetes. What is number 2? If you have read the DoK report, you will know the answer to this question. Hint, hint, our questions will be about DoK stuff, so read our stuff. What's number 2? AI/ML, analytics, storage, or streaming? And it is analytics, and only one person guessed it. It was interesting for us to see that as well, actually, that after databases, analytics, I think in the previous year's report was like number 5 or something. So it really jumped up quite a few steps from 2021 to 2022. So we have Paige G in the lead with Robert closely behind. Awesome. Okay, let's see who gets, I think this is our final question. Who gets the final question here? Which of these impacts does an organization experience once they've been running data on Kubernetes? Productivity gains, revenue growth, market share, margin, or all of these? This is also in the DoK report from 2022. So if you haven't read that, it's a really great report, lots of benefits and challenges and solutions. All of these, yes, all of these are impacts that we heard people identify as benefits they receive from running data on Kubernetes. So who do we have as the final winner here? Ooh, so many people are so close. Robert. All right, Robert is the winner. Is that Robert Hodges? Yay. It is Robert Hodges. Awesome. Well, we know how to get in touch with you, so we will get you your DoK t-shirt. Very cool. Thank you everybody for joining our first DoK Town Hall. We hope you had an awesome time and join us next month for the June one.